Let's understand the idea behind the topic of derivative. Derivative is a way of finding the slope of a function at a particular instance of time. That is, finding the tangent at a point. So basically, with the help of derivative, this is what we'll be able to do. So I have a function f of x versus x, and now we'll need to do this. For example, that is, so we are looking at what is this? This is a tangent. So tangent at any instance of time or point, if we have to figure out, this is what we can do. So here the slope of this line is determining the derivative of this function. That's why I'm able to get the tangent. What does it mean? That's what we are trying to understand. Now let's recap the formula of a slope. Slope is nothing but your rise by run. In another way, in a bit more mathematically, it is change along the y divided by change along the x. Now the phrase rate of change can be used to speak about derivative. That is change along the y with respect to x. Right? So derivative is also the rate of change of a function with respect to another independent element. Okay? Now graphically, if we recall, if I have to figure out the slope of a line, all I have to do is take a point. So this is 4 and respective horizontal, that is the y component, say this is 3, and say another line and the respective y component. So basically over here we are looking at change along the x and change along the y. So this would be 4 and this would be 3. Now slope of this line is delta y by delta x. So we have a rise of 3 for a run of 4. So the slope of this line is 3 by 4. This is an example. The question is, if I have such a system, if I'm able to find the slope of a line, why is that I need a derivative? Why should I derive an equation? The answer is quite simple actually. If I have a function which looks something like this, graphically it looks like this. Now if I have to find the slope, each of this point will have a different slope. Let me explain this with the help of so here I have sine function. So if I move it from say this point, if I start moving, you can see that the slope will keep on changing. It's not a fixed slope. While in a single line, you take any two distinct points, the slope will remain the same. But here it's not so. Here the slope, say at this point, would be something like this, and here the slope will be something like this, and we saw the animation, right? So here we can see that the slopes are different at different points. Is it not? So if I have to determine such a non-linear function, the derivative of non-linear function at basically a different point, we need to determine the slope at a specific point in time of such non-linear function. We use derivatives, the idea of derivatives. So how do you do that? That is what we're going to learn. So this is your introduction, still a long way to go. So do copy it. We are taking baby steps.